Hello everyone and welcome to our next section. Today we are talking about section 8.1, which is right triangles and using the Pythagorean theorem and special right triangles as well. So a right triangle, the Pythagorean theorem is something that we're going to use anytime that we are looking to find the missing side of a right triangle. It is important that you only use this on right triangles. It's not used for any triangle. It's not used for acute triangles, not obtuse, only right triangles. A and B are the two sides that are connected to the 90-degree angle. We call those the legs of our right triangle. And C, the longest side, the one across from the 90-degree angle, that is referred to as our hypotenuse. We've used those words quite a bit this year, but there they are, just formally written down. And what we know is for any right triangle, a squared plus b squared equals c squared. For most of us, that's not going to be new. For most of us, that is something we've been working with all year, and you should be pretty comfortable with. Example 1 has us looking at two right triangles. The first one, we have 8 and 13 as the legs, and x is the hypotenuse. What we have to be careful of is to make sure that we always label the legs A and B and always label the hypotenuse C. The biggest one has to be by itself in the Pythagorean theorem. So I set up my a squared plus b squared equals c squared. I'm going to have 8 squared plus 13 squared. And we'll work through that. 64, 169. Add those up and I get 64 plus 169 is 233. And of course, if we have to get rid of the squared off of c squared, we're going to have to square root it, as that is the inverse of squaring something. The square root and the squared will cancel with each other, so now it's just c, and I just have to take the square root of 233, and I get 15.26 as my solution. On example 2, we have a similar problem. This time though, it looks like they've drawn this part that comes down and intersects at the bottom. Now, because this is an isosceles triangle, what I know is gonna happen is when this comes down and makes its perpendicular intersection with the base of the triangle, it also is going to bisect this side. I gotta use 2 marks because there's 1 marks on the side. Meaning that each of those pieces is going to be half of 22. So this side, those are going to look the same. That side will be 11, and that side will be 11. So now finding the altitude is not going to be very hard. All I have to use is this little right triangle right here. I can even draw a little extra picture of it over here so you can see it a little bit more clearly. This is 11, that's x, that's 24. Again, be careful with your labeling. We know that A and B are going to be my 2 legs, and across from the hypotenuse is C. That's going to be my hypotenuse. A squared plus B squared, I'm going to get 11 squared plus x squared equals C squared, which is 24 squared. So when I go ahead and start doing this, I've got 11 squared is 121, my x squared there. And 24 squared, we may have to put that in our calculator, but you're going to get 576. This one's going to be a little bit different than the last one. The last one, we added these 2 numbers together and then square rooted it. But this time we can't do that because the x squared is part of the A and the B section. So I'm going to have to subtract the 121 from both sides. Bring down my x squared. 5, 5, 4. I get 455. Just like last time, now I can cancel out the squared by square rooting it. That will cancel this and the squared. So now just x is remaining. And I get 455 square rooted is 21.33. I do notice that in this problem, I just did 2 different things. Over here, I didn't plug in x for C, and over here, I did plug in x for B. You make your choice. Whatever makes you happier, you do it. Some little choices right there. I usually plug in x just because that's kind of the way I usually think about it. All right, my last example on here is example 3. In this case, it's asking me to figure out what x is across the bottom of this triangle. Well, what I see is going to end up happening here is what's going to end up happening is I'm going to have to find this piece right here, which maybe we'll call this like M, and this piece here is M again. No, we can't use M again. Let's call this N. And I'm gonna have to find both those pieces and add them together to figure out what x is. So over here in this little right triangle, I'm gonna have a squared plus b squared is going to be the m and the 12. So m squared plus 12 squared equals the hypotenuse c squared. The hypotenuse is the 14 across from the 90, so I get 14 squared. To find n, I'm gonna do the same thing, but you can see the hypotenuse over here is 29, so 29 has to go by itself, which means n and 12 are going to be my a and b. So n squared plus 12 squared equals 29 squared. And now I just got two problems I need to go ahead and work my way through. So I get m squared plus 144 equals 196. We'll subtract 144 from both of the sides. Cancels. I get m squared equals 2 and 552. And again, that last step, square root the m squared, and it'll make it just m. And the square root of 52 gives me 7.211, so 7.21. Boom. Over here, working through my n. N squared plus 144 equals 29 squared, which is 841. Subtract my 144 from it, so minus 144 minus 144. Again, this cancels and I bring down my n squared, and I get 697. And lastly, square root both sides. That will cancel out the squared off of n. And the square root of 697, put that in, I got 26.40. So 26.4, we don't have to put the 0 at the end. Again, though, that's just m and n, right? That's m, there's n, but we want x. Well, x is going to equal m plus n. So in other words, I'm going to need to add 7.21 plus 26.4. And I get 33.61. There is our final answer for that. So a little bit of thinking has to go in to get that one, but there it is. Nothing too crazy. All right. That is going to be the first part, talking about Pythagorean theorem. So now we're going to go on to the next section, which is worrying about special right triangles. Now, this is super important. This is something that I promise you is going to follow you in any advanced math you take. If you go on to Algebra 2, you're going to need this. If you go on to Pre-Calculus, you're going to need this. If you go on to Calculus, you're going to need this. It is super important. So, 45, 45, 90 special right triangle. What happens is these are the degrees of your triangle, right? 45 plus 45 is 90, 90 plus 90 is 180, so it makes up the 180 of a triangle. 30 plus 60 is 90, 90 plus 90 is 180, it makes up the 180 of a triangle. So these are special triangle cases. In this one, you can see that both the two acute angles are equal, so what ends up happening is the legs also have to be equal. It creates an isosceles right triangle. So the legs we're going to refer to as, we can use the little, I use L for it, like a cursive L. And the hypotenuse is across from it, and if you worked it out through Pythagorean theorem, you do L squared plus L squared equals X squared. Add your two L squareds together, you get two L squareds, divide it, blah, blah, blah. Basically, there's a lot of math that we'd put into it, and what ends up happening is the hypotenuse is exactly square root of 2 times bigger. So square root of 2 is going to be this decimal. 1.414213. I don't want you to memorize that. That would be dumb. I want you to memorize square root of 2 because that's easy to remember. So what we do is we put L square roots of 2. So if the leg here is 5, the hypotenuse is 5 square root of 2. If the leg is 10, the hypotenuse is 10 square root of 2. Now, if you get the hypotenuse, you have to work backwards, so you'd have to divide by square root of 2. So just keep that in mind as we go through this, and you're going to see how it works. In 30, 60, 90, the side across from the 30 is the small side, and that's our base side. That's going to be, again, L. And the way that I usually remember this is I go to my biggest side next. The side across from the 90 is the biggest side. The biggest side. So this is L. The side across from it is twice that size, 2 times L. And the longer leg, this is where the radicals come in. It is exactly 1.732050808 times bigger. Again, I don't want you to remember that, though. You cannot memorize that. That's ridiculous. What you can memorize is square root of 3. It is square root of 3 times bigger. So that's what your setups will be. Let me actually finish these pictures. So this is L, L, and L square root of 2. All right, so taking a look then at my picture. These first two, example 1 and 2, focus on the 45, 45, 90 triangle. So what I'm going to start by doing is I start by putting my little labels that I made up here onto my picture. So the two sides that are the legs across from the 90 each get L, L, L. The one across from the 90 is L square root of 2. Well, this problem ends up being easy, because what you need to find is you need to figure out how big L is. This one's really easy because they tell me right away. L equals 8. Well, that means the rest of this is really easy. X is equal to L, which equals 8, so X equals 8. Here, Y is equal to L square roots of 2. Well, I know that L is 8, so I plug in 8 and I get 8 square roots of 2. Meaning, those are your two answers. It's just that. That's all you have to be able to do. Boom, 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 done. Now, something like example 2 is a little bit tougher because when I go and put my labels here, X is L and Y is L. So those ones we know are equal to each other, but I don't know what they're equal to. And 19 is L square root of 2 because it's the hypotenuse side. Well, that means that the key to solving this problem is going to be right here. But it's not solved for L, and I need to solve it for L. So we're going to start with that. We're going to put L square root of 2 equals 19. Remember, this just means L multiplied by the square root of 2. So I just need to solve that. Meaning, to do it, I would divide both sides by the square root of 2. Now, I don't want you to actually divide by the square root of 2 because it gives you a decimal, and we don't want decimals in these. We want them to stay whole numbers. So what we have to do is we have to what we call rationalizing this. You learned this in Algebra 1. We're not allowed to have a square root in the denominator of a fraction. So what we do is we multiply by the square root of 2 on the top and the bottom because that doesn't change. As long as I do what I do on the bottom, I do it on the top, it's fine. So what I end up getting is on the top, 19 times square root of 2 is just like 19 square root of 2. Square root of 2 times square root of 2 is square root of 4, and the square root of 4 is 2, because remember when you multiply two square roots that have the same thing under it, the square root just goes away. So I get 19 square roots of 2 over 2, and I would just check, does 19 and 2 simplify with each other? And they don't, because 19 is odd and 2 is even. But this is like 20 over 2. You would take 20 over 2 and reduce it to 10, and then you have 10 square roots of 2. So always try to reduce these two numbers if you can. But now I have my answer. L is equal to 19 square roots of 2 over 2. X is equal to L, Y is equal to L. That means X equals 19 square roots of 2 over 2. And Y equals 19 square roots of 2 over 2. And there is our answer. So I know some of you might struggle with the radicals, and that might be where your challenge is. So maybe go back and review your radical rules, but you can do this. You just got to know those rules to make it understandable. All right, example 3 and 4 focuses on our 30, 60, 90 triangle. Remember 30, 60, 90, we go across from our smallest one, and that side is L. This one's going to be easy because they already solved for L. Go across from the biggest one, 90, and that side is 2 times L. And across from the 60, that one is going to be L square root of 3, the weird one that has a 3 in it, which is easy to remember because it's 3, 6, 9, 30, 60, 90 triangle, so you have to use the square root of 3. All right, so in this one, again, like I said, it's going to be pretty easy because they already told me that L is equal to 14. Since L equals 14, X is easy because X is equal to 2L. Since I know that L is 14, we do 2 times 14, which gives me 28. So X equals 28. Y is equal to L square roots of 3. Again, I know L is 14, so 14 square roots of 3, and hey, that's it. That's the answer. You can't simplify that anymore. 14 square roots of 3 is what Y equals. I don't know why those are different colors. I'm sorry. It makes me angry. It's going to be recording a video forever. All right, episode 4. Episode 4, example 4. I said video, so I said episode. All right, example 4. Again, you can see that in this, and I didn't talk about it over here, but you can always add the missing angle if you want to. Since this is 60 and that's 90, I could add them up and subtract it from 180, so I know that's 30. So it is the 30, 60, 90. So across from the 30, this is L. Across from the 90, this is 2L. And across from the 60, that's L square roots of 3. So again, this one's going to be a pain because we have to solve for L. They told me that L square root of 3 is equal to 20. So again, we divide both sides by the square root of 3, and that's going to get L by itself. So I now know L is equal to 20 over the square root of 3. But again, I can't have a square root in the denominator, so I multiply the denominator by whatever that square root is. And if I do that on the bottom, I have to do the exact same thing on the top so that I don't change the fraction. Well, square root of 3 times square root of 3, like we said earlier, it gives you square root of 9, which is going to be 3. So it just the square roots cancel and you keep the number inside. 20 times the square root of 3 we write as 20 square roots of 3 as one thing, and then we look at the 20 and the 3. Does 20 over 3 simplify? No. 20 does not divide by 3, so we don't have to worry about it. So then we come up here, y equals L. So again, these ones are really easy. If y equals L, well then I know y equals 20 square roots of 3 over 3, and that's it. Here's a little bit tougher though, because x equals 2L. So I know that I'm gonna have to plug in 2 and multiply it by L, which we said was 20 square root of 3 over 3. Well, remember when you're multiplying a fraction, you multiply the numbers on top with the number on the outside. So 2 times 20 is gonna be 40. Keep the square root of 3, keep the denominator as 3. And then I just look at the 40 and the 3 this time. Does 40 divide by 3 evenly? And still gonna be a no. So my final answer there are those two pieces. Hope that all checks out for you. If you need any help, please, as always, come talk to us so we can get you in the right direction. Have a fantastic day.